In this lecture, I'm going to talk about the variants of cloud computing platforms, all the properties that are common across various cloud computing platform variants. We'll go over them. So we have already looked at in the previous lecture the historical background behind the cloud computing and also some of the driving factors that have helped development of cloud computing platforms. And we have looked at the classification of cloud computing platforms, which is typically based on two factors. One is the service models and the deployment model. Service model means infrastructure as a service, platform as a service, software as a service, etc. And deployment model means how the cloud platform is set up, whether it's a private, public, hybrid, or a community cloud. So what are the characteristics of all these variants that are possible? The variants that are possible depend on, for example, you can have a PaaS platform which is public, or you can have a PaaS platform which is private to an enterprise. So in that sense, you can have each of the service model based variant deployed in a different configuration, private, public, or community, etc. So that gives you a wide variety of variants of cloud computing platforms. Since all of them share some basic common features, so we will go over each of those that are common across the variants. So first one is the programmatic and self-service provisioning of resources. In most of the cloud platforms, computing resources, they are available to the consumers in a self-service manner and in a programmatic manner. What it means is that as a consumer, you do not have to interact with any human actor for receiving any service from a cloud provider. Typically, cloud providers will offer a web-based interface or a programmatic API using which a consumer can interact with the cloud vendor and access and request the services that it offers. For example, if you want to have, let's say, some storage from a cloud provider, there should be some way for you to register to that service and subscribe for it. Typically, it will be a website offered by or set up by the cloud provider, where as a consumer you could register and select the service that you want to request for. Another characteristic that is important and common for most of the cloud variants is multi-tenancy. What it means is that for a cloud platform, there are multiple consumers that are sharing the common underlying computing infrastructure that is set up by the cloud provider. For example, for an infrastructure as a service cloud, different virtual machines of different consumers could be running on a single shared physical host. So in that sense, there is a sense of multi-tenancy. And multi-tenancy, of course, brings up further issues and further implications, which we will discuss and go over in some of the subsequent lectures in more detail. But these are the characteristics that I'm going to list. Actually, they are important from the standpoint of guest application. Like as a designer or as a developer, when you develop applications for different cloud-based platforms, it is important to be aware of these characteristics so that you can either derive some benefit out of those characteristics, or you design your application such that you don't get into the problems that might arise because of these kind of characteristics. Another important property is lack of control, absolute control on the custody of the data or computing assets. What it means is when you subscribe or sign up for a cloud computing service, for example, infrastructure as a service gives you some computing resources, it could be storage or even compute. So the data that you store or even the code that you will deploy there, that resides in the data center of a cloud vendor. So in that sense, you have a loss of control, if you will, on those assets, whether it's data or other computing infrastructure in terms of software, etc., that you will put in the cloud. So you have that sense of loss of control. Another important characteristic is that computing as a utility is accessible over the network. As long as you have a good network connectivity and you are able to reach into the data center of the cloud provider, you should be able to avail all those computing resources. And the services that a cloud vendor provides, they are measured as well as metered. What it means is that a consumer can see in real time that how much resources of the particular service that he or she has subscribed to, how much of that resource quota the consumer has consumed, so that they can tune their application or tune their processes so as to meet their costing forecasts about how much resource they can consume or they are expected to consume. From the provider side, it's important because they want to be able to control how much quota an individual consumer is allowed to expend before they stop providing the service. Another important characteristic is that the location of the services that a cloud vendor provides is or can be often transparent to the consumers. That means if as a consumer you deploy some application in a cloud environment on a cloud vendor, you may not always know where in terms of geographic location or legal or political jurisdiction where your data or your application is actually running. For example, on some of the platform as a service such as Google App Engine, as a consumer you do not know or you do not have much control on where your data that you put through your application onto the Google App Engine framework, where that data is going to reside in terms of geographic location, etc. You do not have much control or even awareness of that location. So if that is sensitive for your application, then this is going to be a concern for that kind of a scenario. Different structure for software licensing. That is another characteristic which is important for cloud variants, that the software licensing is not exactly same as how you would have in a non-cloud kind of environment. For example, for certain types of software, the licensing terms are different when it's deployed in a non-cloud environment, whereas in a cloud environment, the licensing structure could be different. Another important characteristic is that there is a potential to abuse the relative anonymity that goes behind when you register for a cloud provider services. Typically, all that you need to subscribe to a cloud service is a valid address and a credit card. And if someone has illegitimately accessed these details from someone, then they can abuse that and subscribe for different computing resources which they can further use to other malicious purposes. So these are the characteristics which are common across different cloud variants. In subsequent lectures, we are going to look at the characteristics and architecture and some examples of different variants of cloud platforms individually. For example, we will look at infrastructure as a service. What is its typical architecture? What are the properties or characteristics that are specific to infrastructure as a service? And similarly for other variants.